Hey everybody, it's Mrs. Peachy from your WCA physical science class, and in this lesson we will be reviewing the portfolio from Unit 5, Lesson 2, the properties of alpha and beta particles. This will be your final portfolio before your winter break, so hopefully you will be able to complete this kind of a little bit before we leave for break, so in case you have any questions, you'll still be able to reach me to ask them before the new year. So this should not take you very long. It is on your calendar for 2 days, so it gives you plenty of time to get it complete. But all you need to turn in to me is a single PDF document for this. There are some directions I want to make sure I go through with you in terms of where you find the instructions and what you actually need to submit to me. Okay, and we'll talk just a little bit about radioactive decay because that's kind of what this whole portfolio is on. So here I am on slide 3 of this lesson, and you will see the first link here takes you to the lab sheet, which is right here. So the lab sheet is what you're going to save and submit to me. Please remember, as I've always told you, and this is getting a lot better, guys, what you need to do is to right-click on here, click Save As to make sure that you have a copy of this saved to your computer. I would highly recommend, if you don't already do so, that you have subject folders for each of your classes and that you save it in one of those subject folders. If not, save it to your desktop because that's an easy place to locate it. And just make sure you name it something that kind of makes sense. Maybe nuclear decay portfolio or something like that. Then you will make sure you close this window and open the copy from your computer in order to enter into it, because you can just type into the boxes then. You will need to save again to make sure all your changes are there before you attach it to the Dropbox. So hopefully by the time second semester starts, you guys will have that down. The next link on here is to the actual the actual Gizmo. So if I go to the Gizmo, which I guess I don't have open anymore. Nope, that's not it. Here we go. It's going to bring this up here, and this will show you then the Gizmo. You can see the nucleus of the atom here. You can see protons and neutrons, electrons, and what? Positrons, which are particles that are positively charged. They're like kind of the opposite of an electron. It's considered antimatter. Ooh, kind of freaky, huh? And the other thing you're going to need here is you're going to need to go up to where it says lesson info, because that's going to give you the link for the student exploration sheet. And when I open the student exploration sheet, nope, not again, that's wrong. This is the one that comes up. So this is all the directions. This is what you're going to need to do for this portfolio. So I would ask that you do the warm-up, and you're going to do the activity A and activity B in this student exploration sheet. You will not submit this to me though. So many people oftentimes attach it. I don't really want it. It's a lot of stuff on here, but you're going to transfer information from the student exploration sheet to the PDF that you're going to submit to me. So just make sure that you have, all of the information you need. Make sure that it's clear. Make sure that it's, adequate in length so that I can understand what it is that you know. So one of the first things it's going to ask you to do is to observe an alpha particle. When I go on the Gizmo, and I'm just going to kind of move me a little bit to get myself out of the way, get this off the screen too. You can click at the bottom here. There is a play button where you can observe kind of what happens during alpha decay. And right away you can see there is the alpha particle. And it might surprise you because an alpha particle is actually made up of several subatomic particles, 2 protons and 2 neutrons. And if I continue on here, you will see that also some energy is given off during this decay. This is energy in the form of gamma radiation. So alpha decay is actually quite harmful. So this is what's happening inside of a nuclear reactor. This is like a uranium-235. This is what's decaying in a nuclear reaction. This might be 238. I'm not 100% sure on that one. So that's why when you've read about nuclear power plants before and this type of energy source, that it can be something to be of concern because it does have radioactive, decay occurring. Energy is given off as a byproduct of that reaction, and that's good because that's going to heat up the water and cause the turbine to turn and provide us with electricity and stuff like that. But it also can be harmful to people. This type of decay can penetrate through your body and damage your DNA, cause you cancer, and actually can kill you pretty quickly if you're exposed to high levels of it. So it definitely doesn't come without risk. So they're going to ask you some questions about radioactive decay. One of the things that you're going to be asked to do is you're going to be asked to look at the actual nuclear reaction that's occurring. Notice I say nuclear reaction, I don't say chemical reaction, because this is not a chemical reaction. It is not electrons, because we talk about chemical reactions, it's always involving those valence electrons that are either going to be sharing, with each other, or you're going to transfer them, and you have, bonds that are being broken where those basically are bonds between electrons. This has to do with the decay of the nucleus. So you're looking further in at the protons and neutrons. And remember that the nucleus is bound together by the nuclear strong force, and that's, as it sounds, really strong. So the amount of energy that's given off in this type of reaction is actually pretty substantial. That's also can explain a little bit as to why, they can be so harmful to people. This type of reaction, especially the alpha decay. So we're going to show equation and write equation here and kind of see what's happening. So we're losing an alpha particle. Remember, an alpha particle is made up of a total of 4 particles. Now that's not really the number of particles per se, it's the atomic mass or the mass number. Excuse me. That was it. Accident. Okay. Mass number is the number of protons plus the number of neutrons, which in this case is 4. The bottom is basically just the number of protons. So that's going to be your atomic number, 2. So when I push enter here, that's going to tell me that this alpha particle that's being ejected from the atom is actually an atom of helium, essentially. It's made up of 2 protons and 2 neutrons, and that's what helium is. So what's left over? Well, we have to subtract this 4 from the 238 on the top, which would give us 234. And we have to subtract the 2 from the 92 at the bottom, which gives us 90. So this gives us the isotope thorium-234. That's the isotope. So that's what's left over after the decay of uranium-238. Okay? So that's just one potential alpha decay nuclear reaction. Let's look at your student guide again. And it's going to ask you to do a few more of these. It's going to ask you to look at polonium-212, radium-226, and americium-241. So you're going to look at those and you're going to predict the products. Now remember, you don't really have to see this run to be able to predict the products. If you want to, you can go to the Gizmo, which is here, and you can change your starting, change the starting element to polonium or radium. Americium is not an option, but you really don't need to do that because when you get to here, you realize that every single time the second box is going to be helium, 4 and 2. So all you need to do is subtract 4 from 212, 2 from 84. Use your handy-dandy periodic table and find the atomic number of the element that you have created, and it will tell you the identification of it. So it's pretty simple that way. The next section that you need to complete is activity B on beta decay. Now beta decay is, I'm not going to ruin it for you because it's different than alpha decay. A beta particle is not an alpha particle, and they're not made up of the same thing. So I want you to kind of look at that for yourself. You're going to switch this thing to beta decay down here, and you'll notice that right away the element is different. It's a much smaller element. In this case, we have carbon. We could also do iodine or sodium. This is the type of radioactive decay we are talking about when we look at carbon dating. Carbon dating is used to date organic molecules that are roughly 75,000 years old or younger. So for very recent type of fossils and stuff like that. But this is the type of decay that we're looking at. We're looking at what is left over, the ratio of carbon-14 to whatever the daughter product here is. This is your daughter product. Okay? Once you've completed both sections A and B and the warm-up activity, again, remember that you are not turning this in, but you are going to be turning in this. And so you'll kind of be writing out some of that information on here and saving it and submitting it to the Dropbox. So if you have any questions or concerns, you know where to reach me. I would be happy to talk with you and answer those questions for you. Otherwise, good luck with your portfolio and have a happy holidays.